चलो. Now, kinetic theory of gases में we will learn some postulates which they assume, right? They assume what are the things they assume? Gas molecules are made up of tiny particles and they are constantly moving. वगैरह they given some postulates, right? What postulates we are writing? So 7 8 are there. वो postulates लिख लो. So first postulate is gas is made up of large number of tiny particles called molecules. तो इसका explanation जरूरत नहीं है. But only this one you write down. Gas is made up of large number of tiny particles called molecules. Whenever gas molecules are, मतलब gas is there inside container means we are assuming there is a particles are there inside the gas. This is first assumption. Second one, volume of the individual gas molecules is negligible. Yeah, this molecule is so small when compared to the container का volume. That's why volume of the molecular volume is much less than volume of the container. So ये लिखने की जरूरत नहीं, ये लिख लो. Volume of the individual gas molecules are negligible. Next. Third one लिख दिया? Covered. Only write down this one.
You don't need to write the explanation.
No, only this one. This one you know already. Volume of the individual gas molecules is negligible. Assumptions करके they explain everything. All laws are explained by using this kinetic theory of gases.
Yeah, so done.
Next postulate. No intermolecular forces. We are assuming there is no forces between the particles. That's why there is no attraction, there is no repulsion. Okay, in kinetic theory gas mein. Next one is molecules are continuously in random motion. They are always in motion. This one you know already.
Yeah, done, sir.
Next. Collisions are perfectly elastic. Elastic मालूम है ना? Where kinetic energies are equal, initial and final kinetic energies are equal, and momentum is conserved. No loss in kinetic energy during collisions. And time of collision is always negligible. Collision duration is much less than time between the collisions. So time of collisions are negligible. Very, मतलब वो time we are neglecting. कितना time में collisions हो रहे हैं बोल के. And next one is average kinetic energy only depends on the temperature. Very important point. Average kinetic energy, इसका formula याद है ना? Kinetic energy is 3/2 kb into t. 3/2 kb into t. Boltzmann constant है. देखो kinetic energy depends on temperature. More the temperature, more the speed of the molecules, and more the kinetic energy.
Yeah, so done.
Yeah.
So KB is 1.3 into 10 power minus 23, right?
23. Yes. And gas pressure arises due to collisions with the container walls. Pressure is nothing but force upon area, right? So gas, it will exert a pressure because of collisions. That's why gas will always exert the pressure. These are the postulates of the kinetic theory of gases. Assumptions. These are the 8 assumptions which we learned. Okay? Then, chalo. Now, pressure of an ideal gas. एक कंटेनर में the gas is there, okay, that will exert a pressure. कितना exert pressure करेगा for ideal gas means that formula is there. P is equal to 1 by 3 small m capital N by V into V RMS square. This is the formula for pressure of an ideal gas. Very important formula learn करना पड़ेगा. And P is pressure. Small m is always mass of one molecule of the gas. And N is the number of molecules of the gas. V is the volume of the gas. VRMS you have to know. Square root means square velocity. ये आपको सेकंड ईयर में AC सर्क्यूट्स में भी आएगा RMS velocity. And this small m into capital N is nothing but the total mass, right? Molar mass upon volume. Mass by volume is nothing but density. So therefore 1 by 3 density of the gas into V RMS square. These two formulas you have to learn.
Sir, in the second formula,
Uh,
P is equal to 1 by 3 density of gas.
Into VRMS square.
Yeah, sir, but M by V is density, right? So what happens to the
देखो,
N?
this is mass of molecule into number of molecules, nothing but capital M. Mass by volume is nothing but density. Okay. Now देखो इसका. We will see kinetic interpretation of temperature. एक small derivation is there. वो क्या है आपको, as the temperature increases, I told you the speed of the particles will increase and kinetic energy will increase, right? So वो temperature पर कैसे depend होगा बोल के we will take the basic ideal gas equation का, kinetic gas equation का, which is 1 by 3 rho V RMS square अभी जो लिखा ना उस उधर से only we will prove that it is depending on temperature. The VRMS speed is depending on temperature. Okay. So here देखो we are converting density is nothing but mass by volume. I am substituting this density in this formula में. So that is PV is equal to 1 by 3. Density is mass by volume, right? This volume I am multiplying cross multiply like this 1 by 3 m VRMS square. Okay. I want our intention is to find what temperature and kinetic energy.
What's capital M?
Capital M is the mass of the molar mass. Nothing but capital M. Okay. Now देखो ये PV is density equal to mass by volume. M के density के जगह substitute किया and V को cross multiply किया. And we know from ideal gas also PV equal to RT for 1 mole of gas. For 1 mole of gas PV equal to RT. N के जगह में 1 लगाया. So I am substituting PV के जगह में RT because I want in terms of temperature. देखो PV के जगह में RT लगाया. Now if you see carefully, T and VRMS are direct relation indirectly. Temperature, because I'm setting all one side and this is constant, and we got finally temperature is proportional to VRMS square. This is what we proved. So starting say we will define, right, what is temperature means average kinetic energy of the molecules means this only. Temperature is only depending on the average kinetic energy of the molecules. More the kinetic energy of the molecules, more the temperature indirectly. So आपको ये थोड़ा important है, मतलब कभी भी even heat and temperature also we told temperature means average kinetic energy of the molecules is depending on this VRMS only. The temperature of the gas is due to the motion VRMS and vibrations only. उसके वजह से only we are getting the temperature will increase.
So what does this even prove?
What does
this prove?
Prove means देखो as the temperature increases the speed will increase, molecule speed will increase. This is what proof. Okay. So इसमें थोड़ा conversions आपको थोड़ा useful होगा. आपको आगे मतलब KB टू R टू KB, स्मॉल m टू कैपिटल M कैसा करने का, ऐसे स्मॉल स्मॉल विल बी लिंक्ड इन द न्यूमेरिकल्स में, थोड़ा डेरिवेशन पॉइंट ऑफ व्यू लर्न करो हो जाएगा. Okay. Now we will see the relation between kinetic energy and pressure.
Yeah, so you can done that.
Kinetic energy and pressure.
Yeah, so done.
Yeah. Now we will take this relation कौन सा, PV is equal to 1 by 3 m VRMS square लेके we are trying to convert into kinetic energy and pressure का relationship क्या है देखेंगे. देखो relation between pressure and kinetic energy. So what is we got PV is equal to 1 by 3 m VRMS square. This is the thing we got, right? Clear. Now मैं क्या करूंगा, काइनेटिक एनर्जी में प्रेशर तो है, काइनेटिक एनर्जी चाहिए. इफ यू वांट टू कन्वर्ट इनटू काइनेटिक एनर्जी फॉर्मूला इज हाफ mv स्क्वायर, राइट, VRMS स्क्वायर. इधर mv स्क्वायर इज हाफ नहीं है ना, so मैं क्या करूंगा, इस इक्वेशन को आई मल्टीप्लाइंग विथ 2/2. so PV is equal to 2/3 टाइम्स क्या बचेगा, 1/2 m VRMS square. So PV is equal to 2/3 times of kinetic energy. And this is for kinetic energy for 1 mole, right? 1 mole. So now देखो kinetic energy and pressure का relationship आ गया. आपको from this what is the formula for PV equal to 2/3 KE, right? From this kinetic energy is equal to, you can convert into this one. Kinetic energy of 1 mole is how much? Is equal to 3/2 PV. Right? This is the relation between kinetic energy and pressure. 3/2 kV.
Can't we say, oh, no, this is not average. Yeah, okay.
So this is for 1 mole of the gas. 1 mole of the gas. Sometimes they will tell in terms of RT, R. देखो for 1 mole, what is PV equal to? For 1 mole, PV equal to RT. I can substitute kinetic energy of 1 mole is 3/2 RT. ओनली प्रेशर एंड काइनेटिक एनर्जी का रिलेशनशिप ये वाला, ये बैठ करने का, प्रेशर एंड काइनेटिक एनर्जी का 3/2 PV ये वाला. इन टर्म्स ऑफ RT में चाहिए बोलो 3/2 RT. दिस फॉर 1 मोल ऑफ द गैस. ओके, कैन यू कन्वर्ट इनटू इन टर्म्स ऑफ KB में, कैन यू कन्वर्ट इन टर्म्स ऑफ KB, बोल्ट्जमैन कांस्टेंट?
3/2 NA KBT.
3/2 NA, नो.
So 3/2. So KBT by NA into 3/2.
KBT by this is for 1 mole, right? I want for 1 molecule. 1 mole has how many molecules? 1 mole has Avogadro number, right?
Yeah.
If for 1 molecule कितना होगा? Kinetic energy for 1 molecule I'm talking about. मतलब simply divide with Avogadro number. 3/2 RT by NA. Because 1 mole has this one Avogadro number, right? 1 mole has Avogadro number of molecules. For 1 molecule कितना बोलते हो? Kinetic energy we divide with Avogadro number. And what is R by NA? KB, right? So kinetic energy for 1 molecule is 3/2 KB into T. There are different forms है, you can convert. But एक relationship याद रखो, ये वाला kinetic energy and pressure का relationship. इधर से you can convert from one form to other form. Okay? कैसा है, you can, if you do the PYQs you will understand. Simple. कैसा आएगा बोल के 3/2 KB into T. ये याद है आपको, आगे आएगा kinetic thermodynamics में F/2 KT. F/2 KT
Yeah.
बोल के freedom. So but we are in this we are assuming
That's only for
only
one molecule, no? That's only for one molecule, right?
1 molecule का I want. For 1 molecule divide with Avogadro number. R by N is nothing but KB.
Okay, sir.
So here we are assuming only translation motion is there. That's why degree of freedom is 3. So that's why 3/2 KB into T. If they don't mention directly 3/2 KB into T, you can take for ideal gas में.
Sir.
ना चलो no next one. Next one is Maxwell's speed distribution law. Maxwell's speed distribution law. Now what is happening is, suppose मान लो you have a container. Container में gas molecules are moving with different speeds or same speeds. It'll move with same speed or different speeds or gas molecules different speeds. So a Maxwell ने क्या किया? He plotted a graph. He plotted a graph between fraction of molecules and speed. Because exactly each molecule ka speed we cannot tell, right? So average fraction of molecules we can tell. The fraction of molecules are moving this approximate speed is much. This fraction of molecules are moving with this speed. Okay? He plotted the graph. And after plotting the graph, he defined 3 different types of speeds. कौन सा speeds है? One is most probable speed. Second one is average speed. And third one is RMS speed. He defined these 3 things. Okay. So graph कैसा आएगा? First introduce करेंगे Maxwell का. In a given mass of gas, the velocities of all molecules are not same. पहले velocities are not same. Even when the bulk parameters like pressure, volume, temperature is fixed. Even though all are fixed also, the molecules are moving with different speeds. Why they are going with different speeds? Because collision changes the direction and speed of the particles. Because of collisions, एक ज़्यादा speed जाएगा, एक कम speed जाएगा based on the collision speed. Okay. Now he plotted the graph and he defined 3 different types of speeds. Okay. Now इसका graph क्या है देखेंगे. देखो, this is the graph. So these are the fraction of molecules. Y-axis is nothing but fraction of molecules. Fraction of molecules versus speed. Speed of the graph. So what is he plotted the graph, right? He got this the graph. This is the graph he got. Okay, this is the graph he got. Now this the meaning क्या है? These are the different molecules are going with different speed. He plotted the graph like this. Okay. Now देखो example. I took this from the molecules which are moving with v speed and v plus dv speed. Suppose I took 2 molecules का difference वाला. मतलब देखो, suppose one molecule speed is 50 meters per second. दूसरा molecule speed is 50.25 or 50.5. 50.5. I took that many fraction of, मतलब if I find the area of this one, these many fraction of molecules are moving with the speed between v and v plus dv. इसका meaning है. The area under the graph, we are getting the fraction of molecules, not particular one molecule नहीं है. These many molecules are moving with the speed of v and v plus dv बोल के meaning है. मानो understand, बाद में पढ़ो. वो पढ़ के हेडेक आएगा उसमें. वो पढ़ के वो क्या करेगा? सेंगे जब बुक को बाजू में रखा, वो बाद में पढ़ सकते हैं. उनका सम प्रॉब्लम वो वाला क्या है, सम एंगेज में भी सम क्वेश्चंस आर समथिंग रहेगा, थोड़ा प्रॉब्लम हो जाएगा. टर्मिनोलॉजी सब डिफरेंट है. सिंपल वे में एक्सप्लेन कर रहा हूँ, सुनो आराम से. बाद में कर सकते हैं, टाइम रहेगा ना. ओके. सो व्हाट इज द मीनिंग? टेल मी. मानो इसका मीनिंग क्या है? टेल मी. एक ग्राफ में से व्हाट इज कंक्लूजन यू आर गेटिंग? टेल मी.
Yeah, that VMP, like probable speed is the highest compared to.
No. What is this one? V and V plus dv क्या है? हाँ, ऐसे रहेगा. पढ़ो, टेक्स्ट बुक पढ़ो ऑलवेज. तो सुनो बोले तो इतना एजेंसी में करता है. ये 1 आवर में आपको 23 आवर्स बाकी है, आप क्या करेंगे तो उसमें. So what is the meaning is that if I find the area of this small area, if I find under the graph, we will get the fraction of molecules. These many fraction of molecules are moving with the speed between v and v plus dv. Okay. मतलब I told you, suppose मान लो 50 meters per second, 50.25 meters per second. But if I find the area, I will get these many fractions of molecules are moving with 50 and 50.25 बोल के meaning है. Okay. Now graph draw कर लिया. We have 3 different types of speeds are there. One is most probable speed, average speed, RMS speed. Okay. We will see these all things क्या क्या है बोल के. Okay. चलो. तो फर्स्ट वन इज रूट मीन स्क्वायर स्पीड के बारे में लर्न करेंगे. रूट मीन स्क्वायर. व्हाट इज मीनिंग ऑफ रूट मीन स्क्वायर स्पीड मीन्स? रूट
Root of
मीन्स
v1 square is divided by n.
क्या क्या?
Root of the sum of squares of all the velocities.
Yes. So it is a square root of the mean of the squares of the molecular speed. Okay. So it is a speed that directly relates to gas pressure. This speed only will relates with the pressure. Okay. Suppose मान लो इसका फॉर्मूला देखेंगे, root of v1 square plus v2 plus so on to vn square by n. Suppose मान लो the molecules are going with different speed v1, v2, v3 and so on to vn. Okay. Now we want to find VRMS. VRMS. So how to find VRMS? आपको क्या करेंगे देखो, what is the full form? Tell me Grisha. RMS full form क्या है? Root
mean square.
mean square. So when you're doing the numericals, आपको रिवर्स में जाएंगे. रिवर्स में जाएंगे. पहले स्क्वायर करेंगे. तो v1 square, v2 square, v3 square, so on to vn square. पहले स्क्वायर करेंगे, बाद में मीन करेंगे. मीन इज नथिंग बट एवरेज बाय n, एंड बाद में रूट करेंगे. दिस इज अ वे टू फाइंड स्क्वायर, मीन एंड रूट. रिवर्स वे में जाने का. दिस इज नथिंग बट एवरेज जी आरएमएस स्पीड है. रूट ऑफ v1 स्क्वायर प्लस v2 स्क्वायर सो ऑन टू vn स्क्वायर बाय n. Suppose molecules are going with 2 meters per second, 3 meters per second, 4 meters per second. Now calculate VRMS. VRMS find calculate 2, 3, 4.
So root 29 by 3.
29 by 3.
Yes, root 29 by
Root
5.
29 by 3.
Root 3, yeah, 3, right? Yes. चलो. Now देखो, in terms of gas molecules में they'll give molecular mass of the oxygen, nitrogen. उस टाइम में आपको RMS स्पीड का फॉर्मूला साथ देर लर्न करना पड़ेगा. अंडर रूट 3RT by m. Okay, that is equal to under root in terms of Boltzmann constant में 3 kb t by small m. Whenever Boltzmann constant comes, this is mass of one molecule. Mass of one molecule. This is molar mass. Whenever R will come, molar mass आएगा, which we are habituated of writing
So
molar
what is
mass.
the root 3 kbt by m? That's also molar mass. No, that's
The mass of one molecule.
Yeah.
Mass of one molecule. In terms of density में पूछेगा तो, you know density is nothing but Pm by RT, right? Pm by RT. This one we learned. If I substitute in this formula में, in terms of आएगा under root 3p by rho. This is a formula. These three formulas you have to know. Because if I substitute density के जगह में Pm by RT, P भी get cancel, अब 3RT by m ही आएगा. And here very important that m is nothing but molecular weight of the molecular mass of the gas, and that molecular it should be in kgs लगाने का. You have to put in kgs. Very important. Tell me what is the molecular mass of oxygen?
16.
Huh?
Oh, it's in gas 32
32. 32 units are what?
grams.
So आपको क्या करने का, when you substituting here formula में 32 into 10 power of minus 3 लगाना पड़ेगा.
Okay.
kgs पे आने के लिए. Okay, that is important. Okay, then covered. Chalo. Next one is most probable speed. Most probable speed. So when we drew the graph, this is the most probable speed. What is the definition says? It is a speed attained by maximum number of gas molecules. Suppose in a container may, if I take some molecules of a gas, probability of getting more that speed is most probable speed. Maximum number of molecules are moving with this speed. Okay, this many fraction of molecules are moving with this speed v and v plus v dv. And you know the formula for most probable speed also. What is the formula for most probable speed? Tell me.
Root
Root
2 RT by MW.
RT by MW.
Under root 2 RT by M. In terms of Boltzmann constant में 2 kb T by small m, and in terms of pressure में density में 2 P by rho. This is the most probable speed. And area under this dn by v, number of molecules per unit speed versus speed graph will give the total number of particles. Always area under the graph will give the total number of particles, fraction of particles will get. Then,
Yeah.
the next one is average speed. Average speed में already this is beside the average speed रहेगा. It is the average of the gas molecules, is the arithmetic mean of the magnitude of the velocities. So just mean of the velocities are nothing but V average. So formula is under root 8 RT by pi m, under root 8 kb T by pi small m, and under root 8 P by pi rho. This is the formula for average velocity. And सभी में which speed will be more? Tell me. Average या
RMS is the most.
RMS speed. So for that के लिए you have to remember like RAM बोल के याद रखो, RAM. Root वाला RMS वाला VRMS speed is greater than V is average. V average speed greater than V most
Sir,
probable speed.
RMS is the most velocity, but it's the least amount of particles, no?
Least number of particles. Very less fraction of particles only will have RMS speed.
Okay, sir.
Then
Yeah.
okay. Use calculator.
Sir,
and do.
1 second, can you go back? Okay, sir.
Okay. So calculate, use the calculator and do. Calculate the value of most probable speed and average speed. Those speed चाहिए. Most probable speed and average speed. When molecular mass are given in kgs directly, they're given directly. And Kelvin में temperature also given. All should be in temperature should be in Kelvin. Now use corresponding formula and solve. On the video. Sir.
The
R
screen is
value you can take.
loading for me. 1 second.
Yeah. R value you can take as 8.3. Use calculators and solve. formula मालूम है ना? Most probable speed, average speed. In
Sir, I
terms of
got most probable as 350. 352.2. And
Sir,
the
can't we find most
average speed is
probable?
397.3.
So can't we just find the ratio of them and find one of them and multiply with the other?
ratio, separately asking, right? Value of most probable speed and average speed. (8.3) you can take, calculator you can use.
So,
Sir, I
so
got
most probable is 352.017, and for average 0.3976 something.
397.49 and 352.18 most probable speed. Okay, 8.3 लिया ना? No problem. 8.314 लिया. Approximate values आ गया. Okay, चलो. Relation between is one already you know, right? Which is greater already. Vm RMS is greater than V average is greater than VMP. Okay, चलो. करो. JMS questions. This is 2024 question. कट करो. He's asking the sample mixture contains the ratio of the RMS speed of the helium and oxygen gas.
1/4. Wait. No. Oh, no. It's 1/2
देखेंगे.
One second.
2024.
So, are we helium to oxygen or oxygen to helium?
Question is same that only. First is helium only.
So then it'll be 2/2.
So you're saying this one, right? देखेंगे.
Yeah.
Sir, what is it? Wait, sir, helium gas molecular weight is 4 only, no?
So 2
Wait.
Four only.
And for oxygen it's 16, no?
ये सब कुछ बोले तो क्या पड़ेगा? सबसे
Yes,
करेगा.
oxygen gas, sir, I took it as O instead of O2. Yeah, sir, 2/2.
Yeah, 2/2. 32, right? Oxygen का? It is. So minimum 20 elements तो मालूम पड़ने का, right? Next. Is also 2024 only. The root mean square velocity of the hydrogen molecule at a given temperature and pressure is 2 kilometers per second. मतलब VRMS is given. The RMS of oxygen at the same condition in kilometers per second is asking.
Still, I'm not getting any of the options.
So 1 second. So hydrogen
2024.
molecule means H2, right? Or H?
H2 only. Atom
Sir,
is not a molecule, right?
0.5.
देखेंगे 2024.
Sir, I'm getting 0.7.
Okay, no
One
option.
Sir, for oxygen, do you take 16 or 32?
32 oxygen is always वो नहीं रहेगा. See, atom बोले तो you take 16. ये molecule है. Molecule is nothing but 2 or more atoms combined. 32 you should take.
Sir, I got 0.5.
0.5 is answer. What
Sir,
form,
can you do once?
what is the formula you used? Tell me, Krisha. VRMS is?
Sir, √3 RT by M.
एंड आपको दोनों डिवाइड करो, दोनों 3RT/m 3RT/m डिवाइड कर लो, आ जाएगा. इसमें क्या, V ऑफ ऑक्सीजन बाई V ऑफ हाइड्रोजन कितना है टेल में, √3RT/m ऑफ इसका बाई 3RT/ हाइड्रोजन. सो उल्टा क्या, तो क्या आएगा, m रूट ऑफ m ऑफ हाइड्रोजन बाई m ऑफ ऑक्सीजन आएगा. तो कैलकुलेट करो. हाइड्रोजन का मालूम है 2, राइट? 2 by, and VRMS of the hydrogen is how much? The given 2, right? मतलब कितना आएगा?
Sir, H2 we have to take.
H2 only we should take. कभी भी ऑक्सीजन बोले तो ऑक्सीजन वो 2, हाइड्रोजन मींस हाइड्रोजन 2 लेने का. सो इट इज कितना होगा, 4 by 2 by 32 times 2. So 1 by 4, 1 by 2, 0.5. Next. चलो. The temperature of ideal gas is increased from 200 Kelvin to 300 Kelvin. RMS speed of the gas at 200 Kelvin is V naught मान लो. The RMS speed of the gas at 800 Kelvin is how much? In terms of V naught में आएगा.
2√2 V0.
No options. To the 23.
2 V0.
देखेंगे.
So 2V0, 2V0.
आया कृष्णा कितना? 2 V
2
naught
V naught.
because VRMS is proportional to root T. वो याद रखना always. That's why we did out, right? VRMS proportional to root T. Next. So ideal gas है. At this, the ratio of the gas molecule to the average velocity will be is how much of this gas?
So won't it be √3 is to √8 by pi?
I'll give options. Try. √8/3, √3π/8.
√3 pi by.
√3 pi by 8.
Why?
8.
क्या है तो that?
Yeah, sir, I did this.
√3 by 8.
Yeah. Next. ठीक है. Now last one is mean free path. Last topic. Mean free path means, what is mean free path? Tell me. The average distance traveled by a molecule between two successive collisions is called mean free path. Suppose मान लो one molecule gas container में the molecule is moving. This molecule is moving. This molecule is moving. This molecule is moving. This molecule is moving. Okay. So इन दोनों का distance का molecules are moving with different speeds का, right? ऐसा move हो रहा है. इन दोनों को इस collision के बीच में का distance को we call as lambda 1, which is nothing but free path. इन दोनों को कोलिजन का डिस्टेंस को λ2 ऑन द वीडियोस, इन दोनों का डिस्टेंस को λ3, ओके सो ऑन. इसको λ1 λ2 λ3 इज कॉल्ड एज फ्री पाथ, फ्री पाथ. इन सभी का एवरेज किया तो मीन फ्री पाथ. ओके एक कोलिजन के बीच में बिफोर कोलिजन हम डिस्टेंस ट्रैवल करेंगे ना, दैट इज कॉल्ड फ्री पाथ. वो कोलिजन फ्री है, कोलिजन फ्री ले. ओके इन सभी का मीन क्या तो नथिंग बट मीन free path. So λ1 plus λ2 plus so on to λn by n. This is called mean free path. In terms of gas molecules में चाहिए ना हम लोग का फॉर्मूला ये वाला, ये λ1 λ2 नहीं देगा डायरेक्टली. Okay, so we have to find in terms of the diameter, number of molecules terms में चाहिए, that will write. Okay.
Yeah.
तो इसका फॉर्मूला है, लिखो लैम्डा इज 1/√2 n pi d square और pi m d square और kBt by √2 pi d square p, where d is the diameter of the each molecule. D is the diameter of the each molecule. This is diameter. And kb, you know, temperature, you know, pressure, you know, number of molecules per unit volume. This is also important. N is small, n is number of molecules per unit volume. तो ये फॉर्मूला ऐड करना पड़ेगा. And इसमें frequency also they'll ask. Collision frequency is how much they'll ask. Collision frequency. देखो √2 pi d square v bar times n. V bar is nothing but average speed. That is equal to v bar by lambda. This is the formula. Collision frequency का formula है √2 n pi d square v bar velocity. 1 by lambda because
V
you know,
bar like the average velocity.
v bar is the average
root
velocity.
RT by pi, that one.
Average velocity wala, yes. Average velocity of the molecules. v1 plus v2 plus v3 by n. That one. Okay.
So the root RT, the root
1 by lambda means इसको reciprocal करेगा ना. That's reciprocal क्या तो? That only average का pi वाला. And time period का formula mean free mean time बोलेगा. So time period is lambda by v bar because 1 by f, right? इसको reciprocal क्या तो? Lambda by v bar. These questions only they will ask in the mains में. So by this your complete chapter successfully done. पूरा. Okay. So